In this video, we're going to look at the problems from the Chapter 10 review that you had difficulty with, and we're going to start with problem number 16. The theoretical probability of spinning an even number on a spinner is 2/3. The spinner has 8 even-numbered sections. How many sections are on the spinner? So let's start with this fact. The probability of spinning an even number on a spinner is 2 out of 3. So 2 is the number of favorable outcomes, and 3 is out of all outcomes, and it's probably reduced because it says the spinner has 8 even-numbered sections. Well, we know that the evens are right here. That's the number that matches up with the evens. And we're going to use this concept that we've used before, this problem-solving concept of proportions. So 2/3 is equal to, and we're going to come out with the unsimplified probability. Okay, so in the top, the favorable outcomes are, we're looking for the even outcomes out of all outcomes. Okay, so if my evens are on top and the spinner has 8 even number sections, where does the 8 go? The 8 goes on the top. And now you can just solve the proportion. 2 times what gives you 8? 4. Whatever you do to the top, you do to the bottom, so 3 times 4 is equal to 12. So the answer is there are 12 sections on the spinner. All right, the next problem says you flip 2 coins and roll a number cube. What's the probability of flipping 2 tails and rolling an even number? So we break this up into its simple probability parts, which would be what's the probability of first getting a tail, then the probability of getting another tail, and then the probability of rolling an even number on a die. So we know that the probability of getting a tail in flipping a coin would be 1/2, and then the probability of another tail would be 1/2, and the probability of an even number, there are 3 even numbers out of 6 total numbers on a number cube. And now we do the math out. We do 1 times 3 is 3, and 2 times 2 times 6, this would be 4 times 6 is 24. And if we simplify, 3 goes into itself 1, and 24 divided by 3 is 8. So the probability is 1/8 that you will flip 2 tails and roll an even number. Okay, number 19, you randomly choose one of the tiles above and flip the coin. Find the probability of the compound event, which is find the probability of choosing a blue tile and flipping tails. So the tiles that are blue are 1, 2, 3, 4 blue tiles out of 5, 6, 7 tiles. So the probability of blue, there are 4 blue tiles out of 7 total tiles. And we know the probability of flipping tails is 1/2. So 4/7 times 1/2 would be 4/14, and you can divide top and bottom by 2 to get 2/7. All right, let's look at problem 21 and 22. You randomly choose one of the tiles above. Without replacing the first tile, you randomly choose a second tile. Find the probability of the compound event. So the key words right here in the problem are without replacing the first tile. That means that you have dependent probability. That means that the second probability is going to be affected by what happened on the first probability. So let's look at number 21. Number 21 says you're choosing a green tile and then a blue tile. So in this group of tiles, I have 2 green tiles, And that's out of 1, 2, 3, 4, 5, 6, 7 total tiles. So the first probability, or the probability that you'll pull a green tile out first, is 2 out of 7. Let's change that color. 2 out of 7. Now, let's say for this to work, for this to have happened, you had to have pulled out a green tile. So let's say this green tile came out of the bag and is out of the bag. It's not being replaced. That leaves you with 1, 2, 3, 4, 5, 6 tiles in the bag. So you have 6 tiles in the bag. And out of those 6 tiles, you have 1, 2, 3, 4 tiles are blue because that's what you're looking to pull next. So you have 4 blue tiles. Now, if you notice, the denominator's changed. There's one less in the denominator because the tile that you pulled out is being kept out, and it's not available to be pulled when you go in to do the second event. The numerators are different because they're dealing with different colored tiles. So the different colored tiles were green and blue. This is what was in the bag when you started, and this was what was in the bag after you pulled a green one out. This is what you had remaining for blue. Now at this point it's just a simple math problem, and 2 sevenths times 4 sixths, 2 times 4 is 8, 7 times 6 is 42, and you can simplify that, divide top and bottom by 2, and let's put that in there. I would get 4 over 21. So the probability is 4 over 21 that you'll pull a green and then a blue. All right, number 22. You want to know what's the probability of pulling a red tile, not replacing it, and then pulling a vowel out of this set of tiles. So there's only one red tile out of the 7 total tiles. So the probability of pulling a red tile out of the set of 7 tiles is 1 out of 7. Now, if that actually happened, that tile is gone, and now you're looking at what is the probability that you're going to pull out a vowel next. Well, out of what's remaining, let's circle the ones that are vowels. A and E are both vowels. That is a total of 2 tiles out of what's remaining is 6 tiles. When I multiply those two together, I get 2 over 42, which simplifies to 1/21st.